other parts of the world, and Merry Christmas and Happy New Year. So we are entering a new year in, I think, 2 weeks. So I hope that a lot of your goals and a lot of your dreams have been come into fruition or reality. But if not, don't worry, because there are still a lot of opportunities to go through as we go on the changing of our years from 2024 to 25. And I'm very excited for next year as we have a lot of plans to go through for Chain Academy. And we have a lot of series bootcamps planning ahead so that we could able to serve more our viewers, especially those who are with us on the first time of our series. And today I'm very excited to have the live demo of the Solidity code on how does a smart contracts is being created on the crypto space. And we will have a short overview on how does we connect our front end application going to our smart contracts. So if you have questions, guys, by the way, you can always comment down on our comment section, and you can still also follow us on X and go on our Facebook pages, and you can pre-sign up on our bootcamp for next year. So we are trying to help Web 2.0 developers convert into Web 3.0 so that they would have the foundation and basics that they are looking for to start shifting from centralized application to developing decentralized application. Right? So let's start our session for the day. So let's have some pre-installed needs for this demo. So first thing, enabled for you to run your code on your computer, you need to have Node.js so that we will be able to easily connect our front end going to our smart contract. And of course, as we are having our front end in our computer or laptop, we need a server, a local server that will run our front end application. So we will install Lit server on our Visual Studio Code, and I will teach you how to install it in a few minutes. And we also need to have what we call a MetaMask. It's the wallet that will contain our cryptocurrency. So this MetaMask can hold a lot of your cryptocurrencies that you will use for your decentralized application and even deploying your smart contracts on the blockchain network. All right. So this tree is very essential. And of course, your favorite code editor. But right now, we will use Visual Studio Code as it's one of the widely used code editor for development. And some things to remember. So we need to have the front end code. So I will have the HTML code samples here that I've created earlier. So we will save time. And the JavaScript function that we have so that we will be able to grasp the functionalities to connect on our smart contract. And I will also let you point out or on where to find your contract address, which contract address is the ID of the address or the smart contracts that we will create, which we will be using on our front end so that our front end will be pointed directly to our contract. So it's like being the back end of our front end site. And also, I will help you point out the contract ABI. So, contract ABI is the configurations inside your smart contract which enable us to communicate our Solidity source code and into the front end and to the blockchain system. So we will use all of those things later, and I will show you step by step on how we will be able to do it. But first, see this short visualization that I have made. So this is what ABI is doing on our code. So on our front end side, we will have our Solidity source code. And of course, we have our HTML. So our HTML code connecting to the JavaScript will be connected to a medium to connect to our smart contract. And through Solidity code, we will deploying our codes in the blockchain system. And once we get the contract ABI and the address, the EVM or the Ethereum virtual machine, which will be our uh, operating system for the blockchain, for the Ethereum blockchain, we will have the ABI, which will help us to convert our Solidity code into the bytecode, which is the language to communicate with the blockchain network. So we will have this demo step by step. And the same thing when trying to retrieve those files. So from the blockchain network, we also need to use the ABI and the bytecode and try to communicate those things and retrieve it so that we will be able to fetch it on our front end through our logic inside the smart contract. So that is the process that we will be having for today. Okay, so let's start our application. So let's first pre-install these things. So I will not be able to wait for you, but I will show you how to install these things. If you don't have Node.js yet, the first thing we need to do is we go to our browser and we need to go to nodejs.org. Okay, so if you want English /en for English words on the website that they have. And after having this Node.js, go ahead and install this one. So once you have installed Node.js, you will be able to see it in your Visual Studio Code. And for us to know if this is installed, we also need to install what we call a lead server, which will be our local host for our computer that will enable us to run our front end code. So let's do or try to install the lead server. So we need to open our code editor. And in this case, we are having our Visual Studio Code. And we need to create a folder which will be the directory or the place where we will save our front end code. So let's go to desktop, for instance, and let's create a folder and let's name it perhaps as first the app. Okay, so we need to open this folder inside our Visual Studio Code. So how to open this on our Visual Studio Code? So let's go to our VS Code application, click File, open folder, and we need to track down where did we save that folder. So it's in desktop, find it up. So I think this is the one, first the app, and we need to select the folder. All right. So let's have let's install in order for us to install the lead server. But first, take note that you need to get installed the Node.js first in your computer. So after installing it, let's go back to the slide. You will see the command that I put inside the slide. -g lit-server. So this command will enable you to install this package. Okay, so let's try installing this by going into terminal. Okay, let's open our terminal. This is like the command prompt, okay, for your code. So you can simply type npm install. The thing that I put there, -g lit-server. Then press enter on your side. However, I will not install it in my end because I've installed it earlier. So I don't want to double install my on my computer the application that we will be using. But on your end, just click enter and it will automatically get installed. Okay? So let's try if the lead server is installed in our terminal or computer. So let's create a sample code here. So let's create a sample HTML by pressing new file, then index.html. So of course, we need to have the basic boilerplate. So if you are familiar with HTML, it will be easy for you to understand this concept. So let's wait why. Okay, there you go. So the boilerplate, let's name this as, let's say, first the app. All right. So let's put something here. Hello world. And let's try to run the lead server by having its command lit dash server. Then press enter. You need to wait for a few seconds to run it down. So let's wait. So in my end, I think it's running. So there you go. It says hello world. Okay. So I think our front end setup is good. So let's move on the other parts that we need to install. So the next thing that we need to have is what we call the MetaMask. Okay. So what does the MetaMask do in our front end? So what MetaMask is doing is it allows us to have our cryptocurrency used on our application. Okay. So how to install MetaMask on your browser? Going on your Google Chrome, you can easily type MetaMask Chrome extension. Let's wait for a few. And then click on MetaMask Chrome Web Store. And you will be able to see a button here which says Add to Chrome. So try to click this one, and the MetaMask will appear on your extensions like this one. So in my case, the MetaMask has already set up on our browser. So if this is the first time that you will be having your MetaMask, so you need to set up those things that he is asking. And once you finish setting it up, you will be given what we call the unique ID or the unique wallet address. And this unique wallet address will be used later for us to connect our wallet going to our smart contract. So we need it for us to deploy our smart contract on the blockchain network. Okay. So once you are set up, the first thing you need to do is you just need to go to settings. Okay. Then on the settings, you will need to have the advanced. All right. So click it. On advanced, you will see here show test networks. So you need to turn it on in case your settings is turned up. So once turned on, you need to go back on the home page. Let's go back. And when you go here, this is the part where you will choose your network. Okay. So try to click here and you will see the networks available on our blockchain. So the main networks here are Ethereum Mainnet and Linea, a Ethereum on deploying your smart contracts. But on our case, we are just studying, so we need to have a test network so that we will not able to spend a Ethereum that will cost us a lot of money. So scroll down a bit and choose Sepolia. And this is the test network that we will be using. Okay, so choose it. Once chosen, you will be able to use Sepolia. And for us to proceed on our discussion, we need to have a balance on our wallet. So I have here a 0.17 and many more balance. So for you to have a balance also, you can go to a faucet. So faucets are there to provide you a cryptocurrency for your test network. So I can give you an example on where to go. You can go to Alchemy and Faucet Sepolia. So let's wait for a few. Okay, so this is one example. So when you go to Faucet, the overview of how to get a free Sepolia for our test network or free Ethereum for our test network. And it's called Sepolia Ethereum or Sepolia ETH. Okay. So in here, what you need to do is go to your wallet, and this part you will see how important the wallet address is. In your MetaMask, you will have the wallet address. So just click this. So copied, and you just need to paste on this part. And this alchemy, this website will able to give you a zero point 0.1 Sepolia Ethereum. However, this website requires you to have zero point zero 0.01 Ethereum mainnet before you can proceed. So you might spend a little bit for you to have a test faucet. So let's try. Send me ETH. So it will ask you that your wallet must have a minimum balance of 0.001 ETH on Ethereum mainnet. So how to get this? So you might spend a little bit of your money by buying on crypto exchange, or if you have a friend that is willing to give you 0.01 Ethereum, okay, so of course it costs something up. So maybe he or she can give it to you. Okay. So that's how you will have a balance on your Sepolia wallet. So let's close this. So perhaps you have now the balance, just like mine. So let's check my balance again. So again, it's 0.17. So it's a little bit too much for a simple uh, demo. So the first thing we need to do is we will proceed on our smart contracts. So where do we edit and deploy our smart contract? You need to go on the website remix.ethereum.org. So you need to put this link up, and you will be you will be redirected to the online code editor that will enable you to write smart contracts and to deploy it easily without the complications of the structured online editor, which we have in our professional setting. But for learning purpose, most of the codes are being run inside remix.ethereum.org. So this online code editor enables us to write our Solidity codes easily without the complexity of installing those a lot of things that you need inside your uh, smart contracts environment. Okay, so how to create a smart contract. So the first thing we need to do is close everything up so it will be a fresh look for us. So let's put on our contracts. Okay, you will see a sample contracts here. Okay? So these sample contracts are Remix is giving you samples so that you will have a grasp on idea on how does a structure of a contract can be done. All right. And some of my previous contracts are also here on my past demos and on my past practices before. So you can also find your contracts here once you practice everything up. So let's create the new contract. And on our concept for today, the thing that we will be doing is we will have a basic smart contract that will be able to put a balance, okay, on our state variable, okay, called balance. So the goal of this demo is to somehow see how to put a data inside a state variable and how to enable us to show it in the front end. So we will have a state variable called balance. We will put the data inside of it, and we will retrieve the data from it and show it on the front end side. Okay, so that's we will be doing today. So let's create a contract. Create a contract. Let's say it's balance dot sol. So that SOL is solidity. So we have our val.sol. Okay. So the first part of the contract should be the license. So the license that we will be having is the MIT license. So it's a bit of the standard on having the Solidity code for us. So keeps appearing. We'll close this wallet connect and I will explain later what's the purpose of this one. So in balance, that's all. After putting the open source license, so let's have the version that we have, and it's called the pragma. It's important for us to declare the pragma because some versions of Solidity might have a little bit different of syntax in the newest versions of Solidity. And in this demo, we will be using Pragma Solidity 0.8.0. So this is the thing that we will be using for this code. So after having your license, after having the version, so we need to put the contract name. So how to put the contract name inside our code? So just type contract, open and the contract name. So it is named balance. So let's put balance. Okay. And then the curly bracket. Okay. So this curly bracket enables us to enclose or encapsulate the codes that we will be including inside our contract. Okay. So as I said earlier, the demo that we will be having today is having a state variable called balance that will enable us to store a value inside the balance and retrieve that value to show in the front end. So let's create a state variable in our balance. And if you will see the Solidity code, it is like a TypeScript. So if you're familiar with TypeScript, you will be easy to determine the similarities of the two. Okay, so let's declare a state variable. We need to declare the data type that our state variable will contain. Okay, let's have uint 256 means it is unsigned integer. It allows value that is not negative. Okay, so these are non-negative numbers. So we are expecting non-negative numbers. And let's declare here private. This is our scope that we are putting inside our state variable because we just want this variable to be accessible inside the scope of our contract. And we don't want other contracts to access this thing up. Okay, so private and the name of the state variable, let's name it as balance. Right? So now we are having okay, uint 256 private balance. So this state variable will hold the value of our balance. Okay, so we can put a value inside of it, and that's also the thing that we will use to retrieve the value and show it in the front end. Okay, so going back to our code, we need to have the functions to add a value inside the balance and another function to retrieve the stored value inside the state variable. So let's first declare the first function. Function. This is a function that will enable us to put a value inside the balance variable. Okay? So every time that we will call this function, this will put a new value inside our balance state variable. Okay? So function, let's name this as store balance. Okay? So that is the name of our function. So it will be easily called later. Open and close parentheses. And we will set a parameter here. A parameter, if you're coding before, you will easily understand that parameter is a storage that you will have. Okay, and this storage will able to retrieve a data that you pass through on the function. And the partner of parameters is called a argument. Okay? And we all know that arguments are the data or the values that we pass from the caller of the function, going to the parameter which will receive the data from the arguments. So store balance, let's have here uint. So we are expecting the same data type. So we need to declare it uint 256 and let's name it as underscore balance. So this parameter will receive the data that we will store in it, okay, using a text box later. And we will declare this as public. So we are allowing that this function can be accessed by other contracts, okay, in case we share it. So open and close bracket. Okay. So open and close bracket, and we will have the function inside. So our function's goal is to add a new value inside the state variable balance. So we will call our state variable. Let's call it. And let's put the new value. So its new value will come from the parameter. Oops. Balance. I'll try to close this. Later, I will try to connect so that it will not bother us. So I will explain later what's the purpose of that. So, okay, then semicolon. So this state variable will be changed its value based from the value of the parameter every time we call this function. Okay? And you will observe here that there is a gas. So there is an estimated execution cost of 22,492 gas. So gas are the fees that you will consume or use in case you run functionalities inside your smart contract. Because we all know that every transaction inside our smart contracts will be needed to verified by different nodes in our blockchain network. Okay? So that is the estimated cost. So another function for us to retrieve the balance function, let's say get balance. And we don't need to have a parameter here because we are not sending a data for this function. This function is for us to retrieve the data of the state variable. So let's not declare a parameter, but instead we will declare public view. Okay. So we are declaring view if you will remember my past lecture. Okay. So this kind of code will enable the function. Okay. It's like saying to the function that the purpose of this function is for returning a value to the caller or retrieving a value from the state variable or the data inside the smart contract, okay, or the blockchain network. So going back to the code, view returns. So it is returning a base from the function or the logic that we will later have. But we need to declare the data type of what we will return. So we are expecting to return a non-negative number, which is uint 256. That's the data type of the data. Open and close bracket. And then let's have return balance. This balance, okay, is the state variable that we have. And return means returning the value of this variable to the caller of this function. So now we are good to go for our Solidity code. So in this Solidity code, we can able to compile it and deploy it on the blockchain test network. So in order for us to compile this, go to this left side, Solidity compiler, and you can click here, compile, balance, that's all. So the compiler's job is to compile your programming, okay, your codes here into a bytecode. Okay. So our language, so if you will see the codes here, it's like the human language, but of course it needs to be compiled and converted into a bytecode for the computer to understand it better. So click compile. Okay, so after it, you will see here and you will have the ABI here, but I will show you another way on how to look at it. So you will not rely on this part. Okay. So after you compile, you can now deploy the smart contract. Go to deploy and run transactions. Okay, in this part, click it. Okay. So let's have some overview of what to find here. So in the side of deployment, you will first have the environment. This is the part where you will connect the wallet. So if this is your first time using Remix and MetaMask, definitely you didn't connect your wallet on Remix before. So you need to choose here Wallet Connect, click it, and you will have this interface. Click Connect, and you will have the option for MetaMask. So it will connect you to the wallet, and it will ask you some things for security purpose. Okay. So for me, I have connected my MetaMask here, so I will not choose it. So I will choose the injected provider MetaMask. So it means I'm connecting, okay, my MetaMask, okay, to my Remix. Okay. So in Remix, you will see I have Sepolia, the numbers, and then the network. Okay. And on the bottom side, lower side of it, you will see the wallet address and the amount that you have. So this is my wallet. For you to ensure that it's your wallet, you can go to MetaMask and look at the first four digits of your code, or sorry, of your wallet address. So I think 0x649, so it's right. On the last parts, 5195B. So it's the same. And my balance here, 0.17. And it's here, 0.1701, and so on. So that's definitely my wallet. So estimated gas, just choose here the estimated gas limit. Okay, what is the purpose of this? It's for security purpose for us to determine a limit in case it will consume a lot of gas. But for now, let's have the estimated gas. Let's allow Remix to do the hard job for us for the moment, as this is our first time to touch our Solidity code. And for value, these are transaction for choosing a unit in case you are sending cryptocurrency. So it's a harder part. Okay? So for now, let's leave it at 0. So it is for more advanced topic. So we will discuss it maybe in our bootcamp or some other series. Okay? So let's leave it here 0 for the moment. And the contract that you need to deploy. So it's the contract. Remember, it's balance. That's all. Okay. Then afterwards, just click deploy. Click deploy. Let's wait for a few. And your MetaMask will ask to confirm the transaction. It means 0.028 Sepolia. It's click confirm. Let's wait for a few. Okay, let's wait. It's pending. Maybe 15 seconds for it to finish. Let's wait for a few seconds up. And if it's long to wait, so it's quite normal. There you go. So it's created in block 7317991. So this is some of the information of our smart contracts. So if you go here, deployed contracts, you will see the functions we have created. So Remix allows you, okay, it allows you to simulate your functions even without a front end. So you can try it out if you want to. But for today, I will have the demo on connecting this smart contract to the front end. So we will not do the simulation here, but instead we will do it on the front end side. Okay. So this is the address of your smart contract. So we will need it. Click copy. And for the ABI, where to find your ABI? Going back to the file explorer, when you go to artifacts, inside the contracts folder, there is a folder called artifacts. If you click it, you will see our contract name and metadata.json. When you click it, there is a part here that is ABI. So for us to easily copy it, okay, you just need to minimize this part and copy. So later, we will be able to paste it on our front end. So that's all for the smart contract side. Now let's go to the front end side. So going back to our Visual Studio Code, let's create a simple code here. Let's remove this hello world and let's copy the code that I've created earlier. I don't want to focus much on HTML. So it's a basic text box and a button. Okay. Let's have a division here that contains the form. So let's somehow divide our view so it will be easy for us to see. And I will wrap this code so that you will be able to see easily. Okay, so going back, this is our HTML. For the complete code, you can message our page, AR Data Tech, on X or even in Facebook, and I will give you the codes here. Okay, or yeah, I could ask our technical support later and can have this code public so that you will be able to see the codes that we are be using here. Okay, so we have here input balance. So this is the text box that we will have our get balance. Okay. Sorry, store balance. This function will be directed to our remix function. Okay. Let's just go back to our Solidity code. So it will be redirected to store balance. And another button, get balance, will be redirected to our smart contracts in the front end. So this is the function expectedly, and this is the text box. So the next part, we need to have our JavaScript. Okay. So above, let's put it above. Let's have script. Let's have a temporary a variable inside of it. And so our variable, say let and get balance. And another is let store balance. So you need to have a basic understanding of JavaScript to know what's the purpose of this thing. And we all know that this is a simple variable inside JavaScript. Okay? And so this is the variable that we will be using to call the get balance function. The other one is to call the store balance function in the front end. Okay? Below, another script will be created, but the type is module because we will be importing modules that will enable us to communicate to our smart contract. We will need the medium to our front end to communicate to the blockchain network or the smart contracts that we have deployed in the blockchain. So there's a lot of options out there. There's Alchemy, there's etc. Okay. And for today, we will be using a very simple communicator or very simple medium called the esm.sh. So it's a very basic module to import for our demo. So let's import three functions from those library. So import, oops, okay. And in our import, we will call three functions inside of it. Create, wallet, client. So this function, what it will do for us is it will create a wallet client inside the medium that we will be using, which is the esm.sh. So it's like replicating our client or our wallet that we have in MetaMask going to the front end. So it will copy the informations that we have. And then inside of it is custom. Later on, we will see what this custom is. Then get contract. This is the way to connect to the contract that we have deployed. Okay? So it's from this website. I will have it. Okay. HTTPS esm.sh/BIEM. Okay. Another import, okay, is we are using Sepolia, so we need to import also from the collection of chains from this module, because this chain could have other test networks inside of it. And we are calling Sepolia because that is the one we are using, okay, in our MetaMask and in our remix. Okay. So Sepolia from the same website, but you have a slash chains. Okay. So we are connecting with this tree. So we are done importing the codes that we need. Now we need to configure, okay, the configurations for these functions we have called, or these modules we have called. So we need to create our wallet client. Okay. Let's create funds. So it's like a wallet client, okay, as I said earlier, from this module that we have imported, that will enable to connect our user's wallet, which is MetaMask, to the Ethereum Sepolia. It's like a bridge on that for this front end. Okay? So cons wallet client, okay, create wallet client, parenthesis, curly bracket, and you need to add chain, determine the chain that we will be using, and it is Sepolia. The one that we have imported. So Sepolia, and it has a transport. So we will use its own module called custom. Okay, and it's window dot Ethereum. It is the way on how to communicate, okay, our front end going to our wallet, and then later on this will be used to connect to the smart contract. Okay, so I think this is good now. We have the chain and we have the transport. Next, we need to set up, okay, or determine the address that we will be using. And to start it out, we need to have cons, accounts, await, wallet client, dot request addresses. Okay. So in this part, we are calling the wallet client we have created. And by this function, it's an internal function, okay, for this module. So this enabled us to get the address of the wallet created. So as I said earlier, this enabled us to create a wallet in this module we have created, and it will have its own address. And we need to retrieve that. So let's put it inside the same variable. So cons, okay, address equals to. So sorry, we do not put it in the same variable, but we use that variable to put it, okay, inside the address variable. And the address one, okay, came from the result of this wallet client that requests address. Okay. So after doing this function, you will be able to retrieve the data that we are looking for, definitely the address, and you can have that data inside the address that we will be using later for our connection in our smart contract. Okay. So the next thing that we need to have is our contract address and our ABI. So cons, need to declare here balance. Let's say balance contract address. So this is the reference of what is the address of our contract. So where to find it? Go to Remix. In our deployed, this one, copy it, copy address, paste it here, okay, and the ABI. So funds, balance, contract, ABI. And then go to the compiler or the file explorer. So balance meta.json. Let's make it it's here. So make it smaller or don't expand it. So it will be easier for you to copy. So copy this thing, this opening and closing bracket. Going back, paste it, okay, then semicolon on the last part. So that is the ABI that we need. Okay. Afterwards, we're not done yet. We're just configured the infos that we have imported from the module and some configurations that we will be using later. Now, we are entering on the main logics that we will be having. The first one is we need to create an instance in order for you to link all of the things that we have input here. We need to link the wallet client or the wallet. Okay, so I think it's wrong spelling. Good thing I saw it. So create wallet client. So we need to link this one, the wallet we have created for the front end, okay, that will later link to MetaMask. We need this account, okay, await client, the request for the address created. We need to declare our contract address, which will link to the deployed smart contracts inside the Ethereum and the ABI. So you need to link and connect this tree. So how to connect this tree? We need to create a variable that will create the instance or the starter so that you will easily use it inside your functions. So let's have our initiation funds balance. Let's say balance contract instance equals to get contract. Okay. Open and close parenthesis. And then, so get contract, okay, you will see here, it's also a module we have imported here. And this function inside from this module, what it does is to connect the three things that we have here, our ABI, smart contract address, and the wallet we have created so that we will easily know and redirect it on the function on the front end. So let's have the address. Okay, this will be the address of our smart contracts. So copy this one. Yes, this is our address. Okay, then comma. Another thing is the ABI, the configurations to uh, talk with the smart contract. So these are the configurations needed. And the client, which is the client created on this module we have imported. So it's wallet client. Okay. You can put comma or not. Okay, maybe not. Much better because we don't have anything to add. Okay. So after it, we can now use this. Okay, this connection of the tree for our function. Let's have our function here. Get balance. You will remember the two variables you have declared here. So we will be using it, okay, to run our functions. So equals to asynchronous function. Why async? Because we need to wait for this function to finish, okay, for us to retrieve the right data that we need. Funds, balance. So this is the variable that we will store our balance because this is about getting the current value of our state variable. Then await balance contract. So let's just copy this, our connection that we have created or the instance we have created. Okay. Then period, read. You need to declare what is the process that it will be doing. So in this case, we are getting a data from the balance variable or the state variable inside our contract. We are reading it. So we will declare read and then the function get balance. Okay. That's the name of the function inside our contract if you will look back. Okay. So you will look back. Here it is. Okay. So afterwards, so let's put the data. Once this function is done, getting the balance, let's put the data of this variable to our display. You go upside, you will see that our display, downside, you will see that I created here a paragraph that says show balance. And using JavaScript, we will display the results here. Get element by ID. We will be using a simple inner HTML. That inner HTML equals to let's have our template literal. So let's say for example stored value, stored value, and of course the variable that we have. Okay, so that is our balance function. How about the function that will put the data inside our contract? So that will be another function store balance equals to asynchronous, of course, because it takes time to do the function inside our smart contract, and we need to wait for the result of it. Cons balance equals to, we are getting now, okay, we are targeting, for this balance, we are targeting the value of the input that we will have. Document that get element by ID, and the name of our input is balance. So let's put it here. And let's put that value because we're getting the value. So you need to know the basics of JavaScript in order for you to easily understand. But it's one of the properties of using document that get element by ID or the DOM or DOM manipulation probably. Okay? Or document object model. I remember the whole term. So inside the balance, okay, let's have our await function. And this function will enable us to write the new value of the balance. Let's copy our instance. This is our connection from now on. Dot write. So this is our method because we are writing a new data for our uh, state variable. So we will call our function in our smart contract. You go back to our smart contract. It's balance. And remember, our store balance has parameter. And we need to put or provide a data inside of it. So to match our arguments to the parameter, we need to have our balance. Okay. So the thing that we put inside the text box will be go through this variable. And when we call this function, it will have an await and write down the new value based from the text box, going to the function that will change the data of the state variable here. Okay. So I think everything is set up on our front end. The only thing we need to do is to have our demo. Let's refresh it to ensure that everything is refreshed and will run smoothly. So let's have our transaction. Let's have, for example, 100, and let's store it inside our contract. When you click store, let's try if it has an error. So probably our MetaMask will ask for the transaction. So let's have the inspect and let's see for our front end if we have an error. So we have an error here. So an account and let's have our troubleshooting. Okay, 94. Let's go with it. Let's go to our code. Balance value, store balance. It's the on click. So it's on our store balance function. Okay, so there's something wrong with the code. Balance contract, instance, that right, that store balance. Ah, I forgot to put the account here. So if you're writing down, okay, for the state variable, you need to declare for this module we have used, you need to declare the account address. So comma, open and close bracket, okay, and we need to have account, and we need to copy this address here. So that is the module's requirement for us to proceed. So let's try again. Let's have 200 here, store balance, and let's see. There you go. The MetaMask asks us for the transaction to proceed. So this storing of value inside the state variable will consume another fee or gas fee. So it is asking for 0.0027 Sepolia Ethereum. So of course, we need to proceed. Okay, confirm, and you need to wait for a few seconds to take it effect. That's the reason why in the UX UI of decentralized application, you're creating a loaders or even some notifications if the transaction is done or not. So let's try to retrieve if the value, okay, just for the demo, I will go back to the smart contract. So let's have if the value of the state variable balance is 200 based from the text box that we have input. So going back on our decentralized application, okay, where is it? Okay. So going back here, let's click get balance. Let's remove this so that you will not say to me that I'm cheating. So let's click get balance. Let's wait. Okay. So the stored value is 200. Let's try to change it to 500. Click store balance. Of course, MetaMask will ask you again. If you don't want MetaMask to ask you and ask you every time you do a transaction, you can have a settings. Okay. So you can have adjustments here. But because we are studying, so it's better for us to see how does a transaction cost up for a gas. So for today, for now, it's 0.0019. Click confirm. Let's wait for a few seconds. Okay. So we are waiting because I didn't put any UI UX here for notification and loading because it will consume more time for us. So it's a basic demo. So let's try to get the balance if it's really 500 now. So get balance. So maybe it's not yet. Try to click it again. Okay, there you go. So it's now 500. So that's how simple having a smart contract transaction to your front end going to your back end, which is now the blockchain network. So you just need to remember to use a medium for it to connect. You need to have your wallet for the transaction. Okay, so your medium will help you to communicate your front end, connect to your smart contracts. But of course, a medium is just a medium. It is still up to you how you will be able to create the logic inside your contract and automate your transactions if needed. So that's it's the main core of our module for of our demo for today. So we have learned how to create a front end, use a medium, and connect it to our smart contracts with our MetaMask wallet. Okay. So if you have a comment or any question, so you can have now in our comment section. So you will be able to answer our we will be able to answer your questions. And by the way, before we end, I'm also inviting you for next year. So go to our free sign up of our bootcamp for next year. Go to www.chain-academy.io, and you can also follow us on X, Twitter, on Facebook, Instagram. Go to AR underscore data tech. Okay. And you can also follow me on our website on my website adyoung.dev, and go to my Facebook profile. You can search for Alan Lim. Okay. So that's all for today. If you don't have a comment, so if you want to have the code for our demo, you can message us and we will give it to you. Or I will ask our technical support for it to be available in the. So Merry Christmas, guys. Happy New Year, and see you for next year for more things to come in Chain Academy. Bye. Thank you.